Hello and welcome. This is another Fog of War Sudoku, number 9 in my series. It's a relatively easy one, this one, just for a bit of fun. If you'd like to have a go at it yourself, you can click on the link in the description below. I'll just go through the rules first. Normal Sudoku rules apply. Cells separated by an X add to 10, so those two, for example, must add to 10. Cells separated by a V add to 5, so those two, that's half a V there, must add to 5, excuse me. All possible X's and V's are shown. So that means if you get a cell that looks like it adds to 10, but there's no X or V, well, like to 10, yes, but there's no X there, then it can't be possible. Double arrows. Lines between circles add to the sum of the two circles. So those two circles there will add to those two lines there. Those two circles sum will add to those two sum. Black dots are in the ratio 1 to 2, so 1 to 2, 2, 4, 3, 6, something like that. Numbers in circles are in the 4 surrounding cells. So if you see a circle, a little circle with 4 numbers in it, then those 4 numbers have to be in these 4 cells surrounding it. Not necessarily in the same spot, but somewhere around in those 4 cells. And that's all the rules. So have a go at it yourself. There's a link below, and if you get stuck, come back and have a look at the video. Alright, so I'm going to start down here. Now normally you put in 1, 2, 3, 4 because you can have a 2, 3 pair or a 1, 4 pair there. But instead of putting in all those hundreds of combinations, I think an easier way to do this one is to get rid of that and try them each individually, because there's going to be a whole heap of different things for each one. So we'll start off with, if that's a 1, that's a 4, that's a 6, that's a 9, that will be 2 or an 8. And is this possible? So 4 and 2 is 6, that could be a 5. 4 and 8 is 12, doesn't work. So that's a possibility without the 8. So that's one possibility. We'll see if there's any others. Okay, if that's a 2, that's a 3, 7, 6, that's be 9, and that would have to be a 7. And you can't have 2 7s, so that means that's not a possibility. If it's a 3, 2, there's an 8, that's to be a 1 or a 4. 2 and 1's 3. You can't have 3 plus something equaling 3, so that can't be a 1. 2 and 4 is 6. You'd have to have a 3 in there. Now that's not possible either because you've got 2 3's. So that one doesn't work. 4 and 1, that would be a 9. 1 has to be a 2, and 3 can't add to 4 plus something. It's just not possible. So that means our first answer was correct. So that's a 1. That's a 4, that's a 6. Now that one had to be a 2, not an 8, because it made it too big. It's a 5, and that's a 9. And then we have 3, 7, 8 left to go in these ones. Okay, now up to this one. We've got a V there, and we've already got a 2, 4, 1 there, so that one has to be a 3, and that's a 2. What now? This one here, the X, we've already got a 3, 2 there, so we can't have a 7, 3 there, we can't have an 8, 2 there, and there's a 6, so we can't have a 6, 4, so that's got to be a 1, 9 pair. And then I think the easiest way to do this would be to put in, oh, and actually, no, it's got to be a 6, 4. I can't have a 7, 3 there, I can't have an 8, 2, and I can't have a 1, 9. So that's got to be a 6, 4 pair, doesn't it? And that means that's got to be a 6, 4 pair there as well, to go with those two, because there's 2 X's there as well. Now what can go in here? What's left to go in there? We've got 1, 2, 3, 4, there's a 5, 7 and an 8. 5 doesn't go there. So what's possible out of these ones? If we had a 4, 4 and 5 adds to 9. There's not 2 things there that add to 9. 4 and 7's 11. We'd have to have 4 and 7 again, which you can't have. 4 and 8's 12, and you'd have to have 4 and 8 again. So that means the 4 doesn't work with any of them. That tells us that's a 6, 4. And that opened up a whole can of worms here. 4, 3, we've got a 6, 4. We've already got the 6, 4, so it's going to be a 3, 5 here and here. There's a 3 there, so that's going to be a 3, that's going to be a 5, that's going to be a 2, that's going to be an 8, and that gives us this one. Didn't even have to bother adding that one up. So that's a 7 and that's a 5. And then 6 and 5 is 11, adds to that 11, which works beautifully. There we go. And now this pair here has to be a 1, 9. It's the only thing left in that box, because we've got an 8, 2, can't have a 7, 3, can't have a 6, 4. And that leaves a 7. And that one gets rid of the 7 down there. And now this one here, what can it be? Can't be a 1, 9, because we can't have a 1 or a 9 there. There's a 2 there and there, so it can't have a 2. Can't be an 8, 2. Could be 7, can it be 7, 3 that way? Possibly. I think it can. 7, 3 can be. Or it can be 6, 4, but it would have to be this way. 6, 4. Okay. Now what? Oh, okay. Now, will I use it now or not? I will save it for later. I'll use it now. It makes it easier. If you remember the negative constraint in this puzzle, all possible x's and v's are shown. So if that was a 7, there would be an x there. So because there's not an x there, that tells us that one's a 6. So in this puzzle, remembering the negative constraint makes it so much easier. Is there one down here that uses the negative constraint? 6. So that couldn't be a 4, that couldn't be a 1. No, there's nothing down there that uses it at the moment. So that makes that easier. So the 6 now can't go there or there, so that's got to be a 6. And the 8 can't go there, that's got to be an 8, which leaves us with a 1, 7 pair there. Now what can go here? We can't have an 8. There's an 8 there and an 8 there. It can't be 8, 2. It can be 9, 1 at this stage, but it'd have to go, because of that 1 there, you would have to go 9, 1. So we can't have 8, 2. Can we have 7, 3? Can't have a 3 there. Oh, and we can't have a 7 there, but we can have 3, 7 that way around at this stage, I think. Oh, no, we can't, because look, there's another x there. So if that was a 3, 7, that would have to be a 3, and there's a 3 there. So we can't have 3, 7. Can't have 8, 2. Can we have 6? No, there's 2 6s. Can't have 6, 4. So that's a 9 and a 1. And that's a 9. And what does that leave here? Can't have 9, 1. Can't have 6, 4. So it's either 8, 2 or 7, 3. Can it be 8, 2? Well, that one can't be an 8 or a 2. So it can't be 8, 2. So that's got to be 7, 3. It's got to go that way around. There's 7 there and the 3 there. And another one. Oh, that gives us this one. 8. Gets rid of that 8 and that 8. So this one here is either a 6, 4 or an 8, 2. Which one can it be? Maybe I should use the black dot first, but oh god, there's only one number left in this row. 1, 2, 3, there's a 4 there. That makes life easy. So that's a 6. And that's either a 2 or an 8. There's an 8 there, it's got to be a 2. And 1, 2, 3, 4, that's a 5 and an 8 left there and there. There's an 8 there, so that one's a 5 and that one's an 8. And what's left in here? 1, 2, 3 left there. Haven't even done this one yet. Probably should have done that earlier, but not necessarily. So that's can't be a 4, 1. It's got to be a 2, 3 pair. Can we tell where it goes? 2, 3. Can't tell where it goes at this stage, can we? No. What is in this one here? 1, 2, 3. That's a 4, 5, 6. That's a 7, 9 pair. And the 9 doesn't go there. 7, 9. And what does that leave us with? A 1. That row is missing that column, sorry, is missing a 1. And this column needs we've got 1, 2, 3, 4. Needs a 5 and an 8. So I could see what adds up with these, I guess. 5 and 3 is 8. We'd have to have 7, 1. 5 and 2 is 7. Can't be that, so that can't be a 5. So it's got to be an 8. And then 8 and 2 is 10, could be 7, 3. 8 and 3 is 11, doesn't work, so it's got to be 8 and 2, 7 and 3. And that gives us this one, because negative constraint again here, 7, 3 you can't have. So that's a 1, and that's a 7. And these 3 here, we've got a 2, 3, 4, 5, is it? Yes, I think so. And there's a 2 and a 4 there, so that makes that one just a 5. Gets rid of the 5s there. Okay, we can have, well, there's a few combinations we can have. Oh, actually, that can't be a 4 because there'd be an X there, so that's got to be a 2. And that's got to be a 4. And now in here, we can't have a 3 or a 2 there, or a 1, so that's got to be a 4. That's a 1. Then here, actually we might as well do what's left in this whole row here. 1, 2, there's a 3 and a 9 missing there. 3, 9. And this row, 1, 2, 3, 4, 5, 6, 7, 8 missing there. Should give us this one. Yep, that's got to be a 7, 3 now. And gives us these two. So that one. And what's these ones? 1, 2, 3, 4, 5, and a 6. Oh, that didn't get rid of anything much in that one, did it? Oh, except we can't have a 6 there next to the 4, so that's not a 6. So we can't have a 2 next to the 8. And that's all we can get rid of there. Got some more X's here though. What can go in there? I was just looking over here to check if I could do that one, but there's nothing there with the negative constraint over there. 1, 2, oh, might as well just put in what there is. 1, not 1, 1, 2, I said 1, 2, 3, there's a 3, 7, and there's one other number, 1, 6 it looks like is missing from there, 3, 7, 6. That made it very simple. There's a 6 there. Hang on, there's got to be another number, a 4. 3, 7, 6, 4, that should have been. Hang on, better take that back. There might be able to be a 4 there. Oops, 3, 7, 6, 4. There can be a 4 there, haha. Lucky I did that. 3, 7, 4. So that can be, in fact, it can only be a 4, 6. 4, 6. And that's a 3, 7. Oops, I mean not a 3, 7. I got rid of the wrong things. I said it was a 3, 7 and then got rid of them. So that one has to add to 5, so it's got to be a 2 and a 3. That's a 1. That resolves this one now. 7, 3. That's a 9. And down here we have 1, 2, 3, 4, 5, 7, 8. 5, 7, 8. 7, 8. Anything that can't go with anything. 1, 8, 2, 8. No, that looks okay. I think I did those ones. What goes here? 1, 2, 3, 4, 5, 6, 7, 8 missing there. And we'll get rid of 1 down here. And that gives us a 5, 7 pair, so that one can't be a 5. That's got to be an 8. And now up here, what have we got left? Shall I put, if we put these ones in, would that be easier? Oh, I don't know. No, probably this way. We'll do this way. 1, so there's a 2, 3, 4, 5, 6, 7. That's all. 2, that can't be a 7. So these two have to add to either 7 or 4, which means that can't be a 9 either way. So that's got to be a 1. And that resolves these ones. And then we've got 2, 5, 7, 2, 5, 7. So there's one number missing here. 1, 2, only a 3, isn't it? Yep. Now it's got to be a 3. And then therefore that adds to 4, so that has to be a 2 to add to 4. And that's not a 2. Well, that's not a 2. Gives us a 5, 6 pair, which means that's got to be a 2. And what else? The last one up here has to be, is it 4, 6 looks like? And it has to be that way around because the 4 down there. 4, 6. And it looks like, this might be what someone was talking about, it looks like you've got unresolved pairs, but you don't, because you can't have a 7, 3 there. That's got to be a 5. That's a 7, that's a 5, and that's a 7, because if there was a 7, 3, there'd be an X there. And there you go. So not too difficult, as long as you remember the negative constraint, which is that all possible X's and V's are shown. And that puzzle kind of shows you the importance of the negative constraints, actually, because it was a much more difficult puzzle if you didn't remember those. In fact, I'm not even sure if it's 100% possible to do it if you don't remember those. So A good lesson learned there, I think, if you missed doing the negative constraints. Anyway, I hope you enjoyed that one, and I will see you next time.